Hey everybody, this is Mr. Piercy, and what we're going to be looking at today are going to be lines that are going to be tangent to a circle, but they have a common external point, meaning that they're going to intersect outside of the circle. So for the demonstration, I'm going to use a straight edge, a compass, and a pencil of some kind of writing device. So we're going to start by creating a circle on the piece of paper. Don't want to make it really big, but I don't want to make it really small either. Something that takes up a good amount of the page, where you can kind of see things being done on it. And so we'll call this circle C, just to give it some kind of name. And I'm going to pick a point here that I will call A, and I'm going to pick another point on the circle that I'm going to call B. Now you don't have to necessarily do it in the same way that I'm doing it. It's just I realize I have more space underneath my circle than I do on the sides, so that's kind of what I'm doing here. I'm going to use my straight edge to make a point that is tangent to the circle, and really make sure that I make it tangent. Let's go ahead and draw in the radius from C to A and the radius from C to B. One of the properties of tangent lines is that they will be perpendicular to the radius. So I'm just kind of lining up the line on my protractor with the radius here, so I know that it's going to be perpendicular. Let me move it down just a bit. And we see that. And let's do this one here the same way, make it tangent. There we go. Okay, and they don't quite go far enough because we need a common external point, so there we go. So now I have a common external point, and I'm going to go ahead and call that point D. Now, both segment AD and BD are tangent to the circle because we constructed them to be perpendicular to the radius, and they intersect the circle at one point. So now what I'm going to do is, if you want to, you could use your ruler, but I think I'm not concerned about numbers. All I'm really concerned about is, are they the same or are they different? So here I'm opening up my compass to be the width of segment BD, and there's an announcement over the intercom. And if you compare the length of segment BD to segment AD, you will see that they are the same length. So tangent lines that have a common external point are going to be congruent to each other. So here I would say that the conclusion that we can draw is AD is another announcement, BD. Oh, maybe they're just teasing me now. So if I have segments that are tangent to a circle, then they will be congruent. Sorry, there's so many announcements going on in school this morning. Tangent lines that have a common external point will be congruent to each other. So I apologize for all of the announcements coming onto the video here, but there's only so much I have control over.